We've heard of the incredible stories of the impact on people's lives that brain-computer interface technology can have. For this hackathon, my team and I challenged each other to consider how we might be able to contribute to the BCI industry. As a small team of just 5, we recognize that it's going to take much more than just us to make a meaningful difference. It'll take the entire neurotech community. But if we work together, we can fulfill the promise of interacting with our things without talking or touching. It's amazing how far the technology has come in the past few years. Hardware has become more accessible and affordable to people outside of neuroscience and psychology labs. However, we believe there's still a long way to go. Instead of creating a one-off application, our mission at natHACKS was to empower our fellow members of the community, the dreamers, the makers, the hackers. To begin, we set our focus on arming Muse hackers with the tools that they need to make their own BCI apps and experiences. My team discovered urgent needs and pains felt by people trying to make neurotechnology. We learned of the steep learning curves, complex subject matter, and a lack of easy-to-use tools. Our hypothesis was that if we simplified the hard stuff, the community would bring forth the impact that we all want to see. Our software solution translates intention into action. It recognizes mental states and facial gestures. Then it takes these detections and packages them up so that they can be easily used to interact with any internet-connected object.
To make our brain-computer interface, or BCI, we use the Muse S headband and the pedal GUI to connect with our computer over Bluetooth. The pedal GUI includes an API that translates brainwaves into English in real time, making it perfect for BCI applications. For example, using alpha waves from the pedal API, we created a focus score that tells me in real time whether I'm focused or not very focused. But for our BCI, we wanted more options than focus. To add more practicality, we used the pedal API to detect blinks and eye movements. To add our own ideas, we used Python to receive the raw EEG data from the GUI. We added brow movements, such as moving your brow up or down, and winks, winking left or right. This gave our BCI plenty of options to translate brain activity into 7 separate actions in real time.
This form has all the different actions that we have available. We have the different gestures within our application, the pedal metrics app, plus additional classifications that James is doing in his demo that he built this weekend. So you'll have access to all that different stuff. Okay. Everything goes up into the server, and from here we really want to control what do we do with that data. Do we send it all along? Do we ignore it? Do we transform it? For webhooks, especially in the IoT space or just in the automation space, you really just want the one message that matters. And in this case, we want to say, hey, whenever there's an eye movement and the value is true, only send that one request off, which in our case will be off into if this then that. Okay. And then from if this then that, it'll then do whatever you want to do. And in our case, it's going to actuate this switch bot. This is just an example of how this would actually work underneath the hood. This is a mocked out message that would come from either James's working Python code or the metrics API code. Okay, so this is just basically says, hey, if there's an eye wink, I want to actually send a message over. As soon as I hit this button, it'll go up into the cloud, get filtered, and come right back. Send the request, came on back, and there we go. We had Jemima do a cool little demo where we could actually send messages over to her Arduino and have it control LEDs. If you can do that with LEDs, you're on an Arduino, you can do almost anything. And then lastly, it's not science without a robot. Jemima also had a Raspberry Pi receive messages and then send those over to control a Sphero robot.